how? Now we're just going to do why the hell would you bother doing all that, right? There's a few reasons why you would try and do all that, or why you would do all that. So the first reason is, right, okay, it's a really good way, why complete the square? So why complete the square, right? Okay, because it's a really easy way to find the maximum or the minimum value. Maximum or minimum. Okay, remember these are quadratics. Okay, so for example 1, x squared, in example 1 we had x squared plus 2x plus 5, okay, and when we completed the square it was x plus 1 2b squared plus 4, okay. That was from example 1, so I should put in example 1, in example 1, x squared plus 2x, we completed the square in example 1 and that's what we ended up with. Right, if you were to graph this, what shape would it be? If you were to graph it, what shape would it be? Yeah, be a smiley face, wouldn't it? Happy face, right? Because there's an x squared term. When there's an x squared term, it's either happy face or sad face. And if x squared term is positive, when things are positive, we're smiling. So we have a happy smiley face. Is that alright? Okay, right. In this case, this graph has a minimum value, doesn't it? Right? Okay, so the minimum value, girls, when you complete the square, the minimum value, girls, is the opposite sign here. So that says plus 1, so your minimum value is minus 1, and this one is the same. Okay, so minus 1, 4, right? So that stays the same, that's the y value, and the x value is the opposite sign. Okay, for example 2, we ended up with x plus 2 to be squared, I think it was minus 10. So again, it was a positive x squared term, right? Okay, so that means it's a minimum value again, like that. What's the minimum value here? Minus 2, so minus 10, right? So it's the opposite sign for the x and the same for the y. Okay, in example 3, example 3, I rubbed it out, I'd say. Yeah, stupid. What did I end up with in example 3? I ended up with 5 minus x plus 1 2b squared. Right, girls? The minus doesn't matter, okay? It's the x term is still in the brackets on the opposite sign, and the y term is the number by itself. Okay, no change in sign. So that minus won't affect it at all. Is that okay? So it doesn't matter that there's a minus in front of the bracket. It's still opposite sign, same sign. Okay? And the next one was, I can't remember. 5 minus x plus 2 to be squared. So again, this would be a maximum point because these have negative x squared, so these are like this. This one's like this. So these are maximum points. What's the maximum point? The coordinates of this point up here would be what? Anyone? Minus 2, 5. Yeah. Okay. And the last one, the one with the 3 in front of it, what was it? 3 times x plus that one, Say that again. X plus a half to be squared. No, it couldn't be. You took that down wrong. X plus a half to be squared. Sorry? Oh, it's, oh, sorry, I apologize. I completely misunderstood you there. X minus a half to be squared, and what's the other one? Plus 5 over 4?
Yeah.
Right, okay. This is a positive x squared term, so this is a smiley face. So that means it's a minimum point, and what is the minimum point? It's the opposite, that 3 doesn't affect things at all, right? So you just take this number, the opposite sign to this number in the bracket, so what would that be? A half, and the y is this, 5 over 4. Is that okay?
What is the bracket where the 3...
3 minus a half, sorry. That one? Yeah, that's a half. Okay? Sorry. Yes.
How do you know...
Who's speaking? Sorry, I can't see. Yes, go.
how do you know to take out 5 over 4 rather than 3?
How do you know to take the what?
5 over 4 rather than 3.
Well, the 3 is multiplied. It's whatever's added. Right, so it's whatever's added, right, or subtracted. As in 5 over here, 5 here, 5 here, minus 10, 4. So it's not...
Excuse me, please.
It doesn't matter.
Eva Dunn come to reception at the bell, please. Also, Eva Munoz, first year. Just a reminder again that basketball is back Thursday at 3:15 to 4:30 starting from today. A junior camogie match will take place tomorrow against Cashel. The bus will depart from the Dock Road at 11 o'clock. A list of players for the game will be published on Teams later today. There's a school jacket here at reception, and on the label the initials JMCD on it can be claimed. Okay, thank you.
Right, okay. So are we okay with maximum or minimum point? That's one reason to complete the square. Right, the second reason to complete the square would be, if it's in that form, you can find the roots of the equation. Find the roots of the equation is find the and solutions. Find the roots of the equation. Right, so we would have been able to find the roots of the equation before using the minus b formula, isn't that right? Okay, or using factors if there was factors available. Right, okay, but if it's in the completed square form, right, we can find the roots, right, quite easily. Right, so if I have x plus 1 to be squared plus 4 equals 0. So if I have that, right, okay, I can solve that, right, rather than multiplying it out and using the minus b formula, I can just go, well, that's x plus 1 to be squared. Can I just change that to a minus 4 for the moment? Right, I'll show you why in a minute. Right, equals 4. Right, can I change it to a minus 5, please? Sorry. It's just I want the first one to be normal enough looking. Right, is that okay? So that means x plus 1 is equal to the square root of 5, bearing in mind that the square root of 5 can be a plus number or it can be a minus number. I got the square root of each side. So square root of this side gets rid of the squared, and square root of 5 is just square root of 5, and it can be a plus square root of 5 or it can be minus, can't it? Because when you square negative numbers, you get plus numbers anyway. You with me? Right, and then you could say x is equal to minus 1 plus or minus the square root of 5, and that's your answer. One answer is minus 1 plus root 5, the other answer is minus 1 minus root 5, which is what you would have got if you did the minus b formula. Okay, right, I'll just do a second one of those. If I have, will I do that one? No, I won't. I'll do this one. 5 minus x plus 1 to be squared. So this is example 1. This is example 2. So when you complete the square, if you end up with 5 minus x minus 1 to be squared and you want to solve it, so you let it equal to 0. Okay? So that would be not what I'm looking for. No, I don't want it to be 5 again. Sorry, just bear with me a minute. Right, if it was minus 7 minus x plus 1 over 4. Right, is that okay? So that would be minus, oh no, I want it to be plus 7. Sorry, x plus 1 to be squared equals minus 7. Is that okay? Bringing over the 7. Then get this, change the signs. X plus 1 to be squared is equal to 7. Get the square root of each side. So square root of this side is x plus 1. Square root of the other side is just root 7. And bear in mind it can be a plus or a minus. Right? So the square root of 7 is 2 point something. Right? But it can be plus 2 point something and minus 2 point something as well. Okay? So then rearrange in there, you get x is equal to minus 1 plus or minus root 7, and there your roots of the equation again. Okay, so if it's in this form, it's easily, you can solve it easily as opposed to doing the minus b formula. You just do this. Is that alright? There's another reason to complete the square. Right, okay. You can also tell whether the roots are real or not. Okay, so you can determine whether the roots are real or not. Determine. So before we had b squared minus 4ac. Remember that, the determinant? And if it ended up being less than 0, they were imaginary roots. And if it was equal to 0, there would just be one root. And if there was greater than 0, there'd be 2 real roots. Yeah? Okay? So remember, girls, just, you don't need to write this bit down. But remember, if there's 2 real roots, it looks like that. If there's 1 root, it looks like that. And if there's no solution, it looks like that. Sorry. Okay, do you remember that? Okay, so instead of doing, we would have done that by figuring out what b squared minus 4ac, right? But if you have it in real form, so if I have x plus 1 to be squared plus 4, right? And I want to know where does that equal 0, right? Okay, so I end up with x plus 1 to be squared is equal to minus 4. And I get the square root of each side, agreed? So x plus 1 is equal to plus or minus the square root of minus 4. But what's the story with the square root of a negative number? Doesn't exist. So what? So it doesn't exist. You can't get the square root of a negative number. If you try it on the calculator, it will say error because it just doesn't exist, right? So therefore, the equation has no real roots. Right, okay, so basically we can solve, like we did a minute ago on the previous board, we could solve it if it has real roots, and if it doesn't have real roots, right, okay, you can also determine that, because you'll end up trying to get the square root of a negative number. Okay, so that means if I was to graph that, right, it would be up there somewhere. Is that alright? Okay, are we good with that? I'll take that as a yeah. We're delighted. Yeah. Right. Do you know, that's enough, right? As in, there's another few bits in the book, but listen, we'll come across them later on. Okay? Maybe I should do axis of symmetry. Yeah. Okay. So you could determine the axis of symmetry. right? I'm using the word parabola now, right? Okay, what a parabola is, girls, is just a graph of a quadratic. So it's just a graph of a quadratic function. Now, I don't know whether you've heard about axis of symmetry before, because you didn't do a junior cert, you didn't? No. So, like, I would have done it, it would have been the last chapter I would have done before the junior cert. So chances are we didn't do it, right? I don't know about the rest of you. But an axis of symmetry, girls, is a line where you can fold a shape along, right? Okay, look, a line where one, if I was to fold it, you know, in primary school where you painted half the butterfly and folded over the paint, that's an axis of symmetry. Have you heard of axis of symmetry? Right, okay, so an axis of symmetry of a parabola is that line there, okay, of a curve, and if it was this one, it would still be down the middle like that, wouldn't it? Okay, so a parabola is just a graph of a quadratic function, so instead of saying it a smiley face, sad face, the proper word is parabola, just in case it comes up and you go, what the hell is a parabola? It's just either a smiley face or a sad face, right? Are we okay? Right, okay, so this is an axis of symmetry, okay? So if we have it in the form x plus 1 to be squared plus 4, we've already determined that that has a maximum, or sorry, that has a minimum point because it's U-shaped, okay? That has a minimum point because it's U-shaped, and it has a minimum point at -1, 4. Agreed? So its axis of symmetry is a straight line through -1. So that's just, that line is called x is equal to -1. That's the axis of symmetry. Okay, the name of that line, you know, like if you were to draw that out properly, it would -1, 4 would be over here. So it would look like that, right? And the axis of symmetry would be straight down the middle there. So that's the line that always goes through x is -1, and it's just called x is -1. Is that alright? Okay. Just one more example on that. I'll just pick one of the other ones I did. So 5 minus x plus 2 to be squared. Right, that's a negative x squared term because when you square it out, there's a minus in front of it. Okay, so that's going to be a n-shaped curve, isn't it? Right, okay, and the minimum point or maximum point is going to be -2, 5. We already know that. Okay, so -2, 5. So then the axis of symmetry will go straight through that. Agreed? So what's the name of the line that's parallel to the y-axis and it goes straight through -2? What's called? X is equal to -2. Right, and that's your axis of symmetry. Is that okay? Right, okay. So we're going to do page 69 to 70. And you're going to do okay, so you're going to do 1 to 4 part 3. That means do 1 part 3, do 2 part 3, 3 part 3, 4 part 3. Then do 5, 6, 7, 8, 9. Is that okay? Right, on page 69 to 70. And you can start now, and I'll put the pages up if you just bear with me.